Acidity is measured on the pH scale. pH is inversely proportional to the concentration of hydrogen ions in liquids. Acids fall between 0 and 7 in pH, while bases fall between 7 and 14. Some liquids, such as water, are considered neutral, meaning that they have a pH of exactly 7. The United States Environmental Protection Agency defines acid rain as a broad term that includes any form of precipitation with acidic components such as sulfuric or nitric acid. Typical precipitation contains some acidity due to the amount of gases, such as carbon dioxide, that can mix with the hydrogen and create acids, such as carbonic acid. However, acids that naturally occur like this are too weak to release enough hydrogen ions to contribute to a change in pH. The term acid rain is applied to any precipitation that reaches under 5.6, the average pH level of pure rainwater. Acid rain is caused by both human and natural activity. It forms when the gases nitrogen oxide and sulfur dioxide mix with water in the atmosphere. Human activities such as manufacturing, the burning of fossil fuels, and transportation all largely contribute to the amount of nitrogen oxide and sulfur dioxide in the atmosphere, but volcanoes can naturally produce these gases as well. By examining the bar graph in the top right corner, we can see how our industry and power generation are the main contributors to nitrogen oxide and sulfur dioxide formation. Acid rain can be deposited in two forms, wet and dry. Wet deposition is the form that most people imagine whilst talking about acid rain, as it travels in rain, snow, fog, and hail. However, dry deposition occurs about at the same rate. Dry deposition falls from the atmosphere in the form of acidic particles that, instead of combining with precipitation, combine with other particles and create larger flecks. These particles can land on bodies of water, vegetation, and buildings, causing to harm materials, ecosystems, and humans. So what exactly are these harmful effects of acid rain? Acid rain can affect ecosystems by removing nutrients from soils. It does this by releasing aluminum, deteriorating the soil's health, while also making it difficult for trees and other vegetation to take up water. Acidic clouds and fog can strip plants of their leaves and needles. This aluminum that is released into the soil can also become rainwater runoff, traveling into local bodies of water. There, it can cause death to many aquatic animals and those who drink this water. The United States Environmental Protection Agency states that swimming in an acidic lake or walking in an acidic puddle is no more harmful than swimming or walking in clean water. However, when nitrogen oxide and sulfur dioxide react in the atmosphere to form fine sulfate and nitrate particles, humans can breathe these particles in, causing difficulty breathing and heart attacks. Acid rain particles can also destroy the ozone layer and can be consumed through vegetation. Acid rain particles deteriorate structures made of stone, wood, paint, and metal. Modern buildings are significantly less affected than these particles than other buildings, leaving our monuments, statues, and tombstones at risk of destruction. Some famous structures that have already been severely damaged by acid rain deposition include the Taj Mahal, the Notre Dame Cathedral, and the Westminster Abbey. Restoring these monuments can be very expensive and tedious. However, acid rain is now considered to be an environmental success, as many claim that the issue has been solved. In 1990, the Clean Air Act included a regulation on companies to cut sulfur emissions by at least half. These sulfur emissions decreased significantly faster than any had imagined, and at only a quarter of the projected cost. This has served as the environmental inspiration behind the creation of carbon markets and many other attempts to reduce global impact of climate change.